Section 7.5 is on volume and surface area. So this builds off of the previous section 7.3 that we just did on perimeter and area. We are now going to 3 dimensions, the inside of a 3-dimension figure, which is volume, and then the outside of a 3-dimensional figure, which is called surface area. So again, you're going to have a bunch of different formulas on here. Either memorize them, or if you're allowed a note card, put them on the note card. We're going to blow through these really quick. I'm just going to highlight the formulas, but there are a couple of things that I did want you to know. Just like we broke down perimeter and area, let's break down volume. So anytime you see volume, what should you think? You should think the inside of a 3-dimensional figure. Okay, so space, how much air is in the room, how much water can fit in that container. It's the inside of 3 dimensions. Again, this is going to be done by multiplication, but rather than multiplying 2 things, you're going to be multiplying usually 3 things together. So it's multiplication. And then whenever you see your units here are going to be cubed, whatever the unit is cubed. So for instance, it'd be inches cubed, feet cubed, meters cubed, whatever that label is, cubed, anytime you see volume. Versus surface area, let's look at surface area real quick. Surface area is the area of all the faces of the outside. So if you make a box, how much will the box hold is the volume, how much cardboard is needed to make the box would be the surface area. So it's the outside of 3 dimensions. And really what this is it's the area, but it's the area of each side added together. So this really has multiplication and addition. And then your answer for surface area is always going to be your unit squared, whatever that is. So like inches squared, feet squared, meters squared, etc. Okay, whatever your unit is will be squared for surface area. So those are the 2 things we're going to do. Again, we're just going to blow through the different formulas and then get to the examples as quick as we can. So geometric solids, they're the same as our 2-dimensional figures, our plane figures, except now they have 3 dimensions they're closed in. Volume is the measure of the amount of space. Okay, so that's what volume is. Let's go ahead and highlight that. Volume is the measure of the amount of space. Okay. They talk about a rectangular solid. A rectangular solid, instead of just length and width, it now has length, width, and height. They talk about a cube. A cube is still a rectangular solid, except length, width, and height are all the same. So they just use S, S, and S. They talk about finding the volume would be how many cubes fit in this area or in this space. So if you looked at the volume of this shape down here on the bottom of page 1, it looks like if you count the number of boxes, you'd have 1, 2, 3, 4, and then there's 3, so there's 4 wide and 3 deep, so that would be 12. 4 times 3 is 12, 12 per layer, and there's 2 layers, so there would be 24 of those perfect cubes. So we would call the area, or sorry, the volume of that space 24, and then because it's centimeters, it'd be centimeters cubed or cubic centimeters.